Hello everyone, welcome to the new video. Also, Happy New Year. I didn't congratulate 2025 in the last video, so I'm doing this 6 months late. This is going to be a short video. It's going to be an overview of Pelly operating system. By the way, give it a star right here. Give a star on GitHub. This is going to be a short overview of how Pelly works and what I learned while doing operating system development. I'm not really interested in operating system development, more interested in other areas, mathematical modeling, robotics, and different areas. Not bad news. I'm not gonna work on Remote Go a lot anymore. It's going to be open. It's going to be open. It's going to remain a non-profit software development group. It's going to be open. But I'm not gonna focus on new projects really there. I mean, I'm gonna probably make maybe one, but since I'm the only owner, like I work with other people and we make our own organization. So Baker moved its own organization. This means it's a different set of people. But we have still contributors from Ring Go, but like Baker is its own identity, and also I want to work on my personal projects more. Make my personal page richer. But it's like it's gonna close. Ringo is definitely not going to close. I'm going to be less focused on it. I'm going to be more into maintaining more because I'm the only owner and I lost the motivation. But still, keeping the Discord server open. Keeping the community. Community is going to remain open. Right. But let's get back to Pelly. So we use a 16-bit operating system in which assembly and C. We use VCC compiler and SM assembler. Bootloader is from Nanobyte. We use Nanobyte OS Dev tutorial series for we use first few episodes of that series. So I'm not going to go to the bootloader. I don't understand it. Here we have, right before we call the kernel, we initialize our own interrupt table. Set number, set the function called load interrupt. Put this in the table. This is the handler of the interrupt. What interrupt does, call the kernel. Here is kernel. We have initialized the disk. Right, we have a disk here. We have a disk things. We have FAT support. We have BBFS. There's like proto-RAM file system. And the interesting part is actually detecting memory. So we use, this was a huge help, how to detect memory. And this, it was a huge help. How we detect the memory. I actually, by helping me over the Discord server, so big thanks to him. He basically called this function, kind of create a pristine environment. We want to get rid of outside noise from the environment. So we put so the argument BP, that's how you do argument, function arguments between C and assembly in VCC. What you do, this so make an array. This is the memory block. This is like the entry. It has to be the same size. You have to match size, like unit 64, unit 32. You have to match the sizes. That's going to be array. Argument is array. Then we do this. We return the entry count into external variables, extern, and then we use cdecl. Cdecl, it tells to VCC that we're going to communicate with assembly. It's like we're getting value from assembly. We also return the address once more. So the address is this. This is how you do segmentation in x86. And you get the memory map from address, and we just cast the type so it's easier for us to work with it. And yeah, that's it. The PMM and malloc are from Paradox operating system made by Kevin. like use help when I was developing this from OpenOS Dev server, or like I use their help, and yeah, I use their help while developing this. This is also a function I made. That's why you can see it's so bad, because the 16-bit CPUs don't support multiplying directly 64-bit numbers, so you have to divide them to 16-bit numbers, and then you have to multiply the 16-bit numbers and add up those parts. This is my function. I did it in C. You can also do it in assembly. So linker calls it automatically. So you can do A times B. You don't have to do function A, B. But okay, here we have a GUI. So basically we define a screen, we have defined some windows. Here I have defined buttons. It's very manual way. Right, it's very manual way. But here you can see the GUI structure of the window, what every window has, every screen has. And this is the actual logic implementation. It was really fun playing with all the positions. Some Euclidean geometry. Right. Last thing I want to mention here, I said it's gonna be short, is user input. Okay, we have a libc, but that's like this from Stack Overflow. This is like from Nanobyte, I think. Maybe even ChatGPT. I didn't do this. Stefan did this portion. So yeah, we have this C keyboard loop. This is the main keyboard loop. What it does, it fetches the key from assembly. And we use integer interrupt 16. For more info, Stanislav's list is a great one. It's very simple, very minimalistic, and has lots of information here. Interrupt 16.0, keyboard scan code, wait for key press and read character. That's what we do here. Get user input. If it's special value, assign special value so we can recognize it more easier. It's more easy to recognize it. If it is ASCII key, do this, backspace do this, character event do this. So normally when you do normal typing, you would get it will be printed out, but we only allow this in several applications. Again, as I said, GUI is very manual, but it is what it is. By the way, the first version of Pelly was released in March 2024, but yeah, you kind of forgotten some things. So here is this code. Why we update the cursor again? When you do printf, you see the cursor moves, but that's actually only a fake cursor moves, because when you start typing again, real cursor didn't move. So when you use printf, we have to move a real cursor too. So that's why these two lines exist. And also for up cursor, we call up cursor a function from which is defined here in assembly. Again, just using the interrupt. Check out Stanislav's list. Here is move real cursor. This is again how you do parameters. BP. I think they are 16-bit size, maybe 8. I don't know. Check it for yourself. This is how you get the real cursor position. Again, external variables, and then C decal. And we have also for clear screen and format change color functions. Another thing, last thing I want to mention is how we wrote ourselves disk, write disk image. I mean, it's usual things, but as you know, segment goes before offset. Segment goes in this register, offset goes into this register, and segment is like first, but it goes, but it's a little bit different because of little endians. They are actually in reverse order. So actually this is data. So you pass the pointer, there is segment of the pointer and offset of the pointer, and the segment part is actually this lower half. So watching it from like this, you would say that this plus 16, this is plus 16, this is plus 14. But because it's little endians, this is plus 16, this is plus 14. Plus 14. So yeah, be aware of that when playing with 16-bit interrupts. Now, as I said, so let's close all the tabs. I said it's gonna be very short video. First, I'm going to demonstrate to you a Pelly that we have on the Ring on Go channel demonstration video. So we have here a calculator. Enter. We're going to enter operator now times. This was the best I could do. Times 7. Second number. Enter. 6 plus 7 is 13. Let's change the operator to multiply. Can reset and enter 14. Now what I wanted to say is that I've left Ring on Go for a year now, and as I already talked at the beginning of the video, I'm the only owner of Ring on Go. Said I'm going to keep the community open. I want for community to remain active, so Ring on Go is going to stay open. It's kind of cool to have your own development group, but since I'm more focused on other projects right now, I don't think I'm going to be coming back to old projects. There is a plan for the second version of Pelly, which will feature Unreal mode. In Unreal mode, you get the access to BIOS interrupt, but you also get access to 4 GB of RAM. Here you only have like 65 KB due to the limits of 16-bit registers. And also we could switch also not better BBFS, real RAM file system, and also what we should implement is our own drivers, because using BIOS interrupts is not very good. And now, like this video, subscribe to my channel, also stare the GitHub repository, check out the Baker, it's its own organization now. Check out Baker, check out Ring on Go, check out my personal projects, and as usual, like and subscribe. Even if you didn't like this video, you don't like programming, and give nothing but subscribe to my channel nonetheless, and see you in the next video / live stream.